Hello everybody, get ready to do SAT Math Level 2 Prep Section 2, which is about linear functions. And today in your notebook, we have 0 points in your notebook, and then 6 points will go into your classwork sheet for this lesson here. About linear functions, I'm going to get into definitions, slope, distance, and midpoint. Name, date, period, if you're in my classroom, due date for onliners, homeschoolers. We're going to start out here with a notebook entry. The equation of a linear function is L of x equals mx plus b, and its graph is a line if x1, y1 and x2, y2 are any 2 points on the line. The slope of the line is m equals y2 minus y1 over x2 minus x1, and the y-intercept of the graph is b, the value of y when x is 0. So that's your y-intercept. Vertical lines have undefined slopes and are not graphs of functions. When given the slope m of the line and a point x1, y1 on the line, a point slope equation of the line can be written readily as y minus y1 equals m times quantity x minus x1. The slope-intercept form may then written if required by solving this equation for y. The general equation of a line is ax plus by plus c equals 0 if b does not equal 0. So b cannot equal 0 here. This equation can be solved for y. Y equals a over bx minus c over b. Thus the slope is m equals negative a over b, and the y-intercept is b equals negative c over b. So this is just like another way of looking at the general equation of a line. If b equals 0 and a cannot equal 0, the general equation reduces to x equals c over a vertical line. Other important facts about non-vertical lines. So parallel lines have equal slopes. We should know that. The product of the slopes of perpendicular lines is -1, or the slopes of perpendicular lines are opposite reciprocals is another way of putting that. So the slopes of perpendicular lines are opposite reciprocals. The distance between 2 points x1, y1 and x2, y2 is found by going the square root of x2 minus x1 squared plus y2 minus y1 squared. That is our distance formula. The coordinates of the midpoint of x1, y1, and x2, y2 would be x1 plus x2 over 2, and then y1 plus y2 over 2. So that would be your midpoints of the coordinates of the midpoint. The slope of a horizontal line is 0, and its equation is y equals b. So here is a tip, students. The standard window on the most graphing calculators is defined by the intervals negative 10 and 10 in both directions. Because the screen is not square, perpendicular lines will look distorted. In order to achieve a visual of perpendicular lines in a graphing calculator, key zoom and then z-square. So if you hit zoom and then hit z-square, you'll get a screen that will show perpendicularity of lines. How about that tip? Okay, let's get into example A here. Describe the line 3x equals 12. So divide both sides by 3 to get x equals 4. This is the vertical line 4 units to right of the y-axis. And then B, describe the line x minus 3y minus 6 equals 0. So to solve for y, when you solve for y here and you move everything else over here, you get y equals 1/3 x minus 2. The slope is 1/3, And the y-intercept is -2. So when you move everything over, you get a y-intercept of -2 for this expression here. And then C, write an equation of the line that contains the ordered pair 6 and -5 and has a slope of 3/4. So in point slope form, the equation is y plus 5 equals 3/4 x minus 6. So this would be a point slope here. We have a point here. This is y1, and then this would be x1 over here. And then we find our 3/4 here. The distance between 2 points P and Q, whose coordinates are x1, y1, and x2, y2, is given by the formula distance equals the square root of x2 minus x1 squared plus y squared minus y1 squared. So that'd be how we would find distance. The midpoint M of the segment, line segment PQ, has coordinates of x1 plus x2 over 2, and then y1 plus y2 over 2. So, for example, D here, write an equation of the line that contains 1, -3, and then -4, -2. So we need to write an equation of a line that contains these ordered pairs here. So to do that, first find the slope, and our slope here is -2 plus 3, so it'll be -2 plus 3 here, and then -4 minus 1. This equals 1 over 5. Then use the point 1, -3, and this slope, so we got our slope, and then we have a point. To write the point slope equation here, y plus 3 equals -1 over 5, multiplied by x minus 1. So we've gotten that far. And then E, the equation of a line, of this line here is y equals 2x plus 3, and the equation of line 2 is y equals 2x minus 5. So these lines are parallel because they both have the same slope here of 2. This one has a slope of 2. This has a slope of 2. And the y-intercepts are different. So over here, this is -5 is our y-intercept. And then over here, our y-intercept is 3. So they are parallel though. And then for here, F, the equation of line 1 here is y equals 5/2 x minus 4. And the equation of line 2 would be y equals -2 over 5x plus 9. So, okay, so let's write an equation of that. These lines are perpendicular because this is the negative inverse. -2 over 5 is the negative inverse of 5 over 2, right? So they are perpendicular. -2 over 5 is the negative reciprocal of the slope of line 1, which is 5 over 2. You can use these facts to write an equation of a line that is parallel or perpendicular to a given line and that contains a given point. So once we know that they're perpendicular or parallel if they have both the same slope. Okay, G here, example G. Write an equation of the line that contains 1, 7, and is parallel to the line of 3x plus 5y minus 8 equals 0. So how would we do that? The slope of the given line is a over b, negative a over b here. So negative a over b. So it would be the negative of that will be -3 over 5. That'd be our slope. So we know that the point slope equation of this line contains 1, 7, and is therefore y minus 7 equals -3 over 5 x minus 1. So there you go. That would be your point slope equation of that line. So H, your example H. Write an equation of the line that contains -3, 2, and is perpendicular to y equals 4x minus 5. So for that example, The slope of the given line here is 4. Here's our slope, 4. So the slope of a line that's perpendicular to it would be the negative 1 over 4. So we're looking for a perpendicular line to this line. It would have a slope of negative 1 over 4. The desired equation is y minus 2, because we're going to use this point here, equals negative 1 over 4x plus 3. So that would be the equation of a line that is perpendicular to this line and goes through this point here. And then an example, I, given point 2 and negative 3 and point negative 5 and 4, find the length of line segment PQ and the coordinates. So PQ would equal, we're going to put these underneath a radical, so the square root of negative 5 minus 2 quantity squared plus 4 minus the negative 3 quantity squared. And then when you do all the arithmetic here, you come up with approximately 9.9 here as the length of our line segment here. And the coordinates of the midpoint M. So now we need to find the coordinates of the midpoint now of this line here. And to do that, where a midpoint would be 2 plus a negative 5, 2 plus a negative 5 over 2, and then negative 3 plus a 4 here. So negative 3 plus 4 over 2. And we get negative 3 over 2 and then 1 over 2. That would be our midpoint for this line here. And find the length of PQ and the coordinates of the midpoint. So given point 2, negative 3, and point negative 5 and 4, find the length. Here's our length, 9.9. And then our midpoint of that line would be here. Negative 3, 2, then 1 over 2. And that is lesson 2, linear functions for SAT Math Level 2 Prep. Animated PowerPoint Math Video with AOL.com for questions or course materials. Thank you very much.